Okay, so this video will show you the difference between a linear and versus a nonlinear relation, okay? And so we're going to show you different scenarios. First of all, the first one is just looking at a graph. It's quite easy. So just by looking at a graph, you can see if your relation is linear or nonlinear, just by looking if it's a straight line or not, okay? So the first one, straight line, linear. Second one, not a straight line, so nonlinear. This one, as you can see, are just coordinates, okay? And so if we were to draw it, it would be a straight line, okay? And so it is linear. And looking at these equations here, they're all over the place, not creating a straight line, so nonlinear. All right, so this is how you decide with a graph. When it comes to table of values, you need to look and see if there's a pattern on both sides. The pattern does not have to be the same, but you need to make sure that within the same column, the x's and the y's, the pattern does need to be the same. So what I mean by that is, if you're looking at the pattern from one coordinate to the other in the x column here, they go up by 100. If you look on this one, they go up by 10. Again, the pattern is not the same, but what's important is that within the columns they are. And so this would be a linear relation, and if you were to graph this, it would be a straight line. If you're looking here, the pattern is +1, the pattern here is +5, but then it jumps to +10, okay, which is again +10. So the pattern is not the same, making these coordinates nonlinear. I do want to specify something. If you had +5, +10, +15, it looks like a pattern, but it's not a linear pattern. Okay? The pattern needs to be the same within numbers. All right? Coordinates. Oh, I knew I was going to do that. Okay, so when it comes to coordinates are just basically these tables are just coordinates put in a table. All right? So you still need to look at the pattern. It's the same thing. So if I look at all the pattern between my x's here, we go up 4, and if you go within your y's, you go up 2. So perfect, this is linear. If you look here, pattern goes up by 1, perfect, every single time. Goes up by 5, goes up by 5, goes up by 5, perfect. Both of them are linear. All right, coordinates. Okay, the last one is knowing if an equation is linear or non-linear. Basically, probably your teacher, to get you to realize how to just by looking at it know if it's linear or not, you did a table with coordinates with this equation, and you realized that it was a linear relation. It was a straight line. If you would have done the coordinates for this one, you would have realized it was not a straight line. Basically, what we tell you is to look at the exponent, and if it is bigger than 1, it is nonlinear. So this would be a quadratic equation. So this would be nonlinear just because of that 2. Okay, the minute there's an exponent 2, this one has an exponent of 1, so this would be linear. If you look at these two, they can confuse some kids. I want you to, in your mind, think about what that would look like. So when I have a graph, and I say that x equals 4. What that means is, when I go to x equals 4, which would be right here, okay, it means that my line, all my coordinates would be x equals 4, okay? This is a straight line, making it linear. And same with this one. If you do the opposite for y equals 1 would be right there. Basically, this would be the line that represents y equals 1, making it a straight line, meaning it is also linear.